One of the most common questions about circle geometry is, how can we put a square, like this blue square here, inside of a circle? What is the largest square we could put inside? Most often where this question pops up is in terms of lumber industry taking a round tree of a known diameter and trying to determine the biggest square post they could make out of it. In order to tackle this problem, we have to consider a few different things. One, all the sides in a square are the same length. So each side carries the same length. If I'm to cut this square up into quadrants, I recognize that each of these individual squares, such as square 1, 2, 3, and 4, are all the same size. So their respective side lengths, such as from here to here, are the same size as from here to here. That's going to become very important because we're going to have two unknown sides when we try to figure out the diameter of the square that will fit in there. So once again, we have a radius. However, the radius must be drawn with a certain amount of care this time, because I don't want my radius to go out to here, because that's not going to help me. It doesn't stop anywhere on my square. However, if I draw my radius here, it certainly does stop right on the square. So, let's set up a problem then. Assume the radius is 10 centimeters. It's a pretty small little tree. What are the dimensions of the biggest square that would fit? So when we start labeling this guy, my radius is 10. My other sides are unknown. So I'm going to construct a triangle using this red line here, my radius. This side of the square, I'm only going to come halfway down and then come up into here. Keep in mind, I took this big square and cut it up into smaller squares, which told me that this side length is the same as this side length, which is also the same as this side length, and this side length. So, setting up the Pythagorean theorem, a squared plus b squared is equal to c squared, immediately, c squared is, or c is 10, so I can throw that in. However, I have two unknowns. I have a and b. I don't know anything about those sides. So it looks like my formula has two unknowns and only one known. However, there is a clever trick to get around this. I know that side A is equal to side B. So if A equals B, everywhere I have an A, I can just put in a B. So then I have B squared plus B squared equals 10 squared. If I have two variables that are exactly the same, raised to the same exponent, such as the b squared and the b squared, I can simply add those together and get 2b squared equals 10 squared. Now at this point, it's just a matter of doing the algebra. So my bed math tells me brackets exponents first before I do any division. So 2b squared equals 10 times 10, just 10 squared there, is equal to 100. Now I'm going to have to divide both sides by 2 to get my b on its own. Divide by 2, divide by 2. And b squared is equal to 50. Then I take the square root of both sides. Therefore, b is equal to the square root of 50, which is about 7.07. So that's grand. So I have found the length of side b, which is 7.07. So therefore, you might say the dimensions of my square then are 7.07 by 7.07. However, keep in mind that side b was only half of the square. So I actually need to double that to get my dimensions. Shuffle her down. Now I can write that over here. Side B is 7.07 centimeters. However, this is only half of the dimension. Therefore, I have to divide it by 2. Thus, the side length is 7.07 times by 2, which is 14.14. Kind of a fun number to pop up. So, if you were to draw your square, you would say that is 14.14 by 14.14. And that's how you figure out the biggest square that would fit inside of a circle.